EIGRP Neighborship. In this video, I am going to talk about the first step in the EIGRP process, the neighborship. What is the neighborship? You know that when two routers needs to send to each other the EIGRP updates, they should first communicate with each other, and after that they are establishing the EIGRP neighborship between them, and then they can communicate over that neighborship. Here we are learning about the detail of the neighborship and also some other features such as the hello time, such as the hold time, such as the authentication, and some other things. This is one of the most fundamentals videos in this series about the EIGRP, and also this is so useful for the troubleshooting of the EIGRP. When you are encountering with one problem in the EIGRP network, one of the most for example, useful information that you should have to find the reason of the problem is the detail of the EIGRP neighborship. Let me start to talking about the EIGRP neighborship. You know that we have here, as you can see, one simple network. In this simple network, we are learning about the EIGRP neighborship. And let me to say that when you are configuring one router with the classic configuration or another router with the for example, named configuration of the EIGRP, about the EIGRP neighborship, we don't have any difference. This means that we can configure EIGRP with each method, okay? And about the neighborship, the result is same and the condition of the neighborship is same. First, let me to introduce what is happening when you are configuring EIGRP on one router. Assume that here we have router 1 and router 2, and then we are enabling the EIGRP on the interfaces of the router 1 and also on the interface of the router 2. I will show you this, but first let me to talk about the concept. After that we can configure the scenario. Assume that with the commands that you have learned before, I am enabling the EIGRP on this interface and also on this interface. What is happening? When you enable EIGRP on one interface, one of the first things that is happening is assigning one multicast address to this interface. You know that each interface has one unicast IPv4 address, okay? For example, in the router 1, the fast Ethernet 00, this interface, the LAN interface, has the unicast IP of 192.168.11/24, okay? But this interface can be assigned, to this interface we can assign one multicast address. EIGRP has the one reserved multicast address such as the OSPF, okay? In EIGRP, the reserved multicast address is the EIGRP multicast address is 224.0.0.10. This is the reserved multicast address for the EIGRP. Because of that, when you are enabling the EIGRP on one interface, we will have this interface also, this multicast address also on this interface. We don't have any problem for assigning multiple multicast IP address on one interface. One of the multicast address that we have on this interface is the EIGRP multicast address. We will use it and I will talk about that. 224.0.0.10. Actually, now on each of these two interfaces, we have the multicast address 224.0.0.10. Also in router 2, when we are enabling the EIGRP, okay, this multicast address now is enabled. You can, I think, assume that this is the M means multicast IP v4 address, and now here on all of these interfaces, beside of the unicast IP address, we have one multicast address. Okay, maybe you ask me why we need the multicast IP v4 address of the EIGRP. I will talk about that, but before talking about the multicast address, let me to say that in EIGRP we have multiple type of packets, okay? Each packet is using for one or maybe more than one function. One of the packets that in EIGRP we are using it is the hello packet. Also, beside of the hello, we have another packets. Let me to write here. For example, we have the update packet of the EIGRP. Also, the next packet is the, for example, query packet of the EIGRP. And also the next is the reply message of the EIGRP, and finally the next packet is the acknowledge of the EIGRP. I will talk about all of them in this course. Because of that, you will learn about them. But for now, let me to say that for the neighborship, we are using only the hello packet. This packet, this message of the EIGRP is using for the neighborship, but other packets, update, query, reply, and acknowledgement are using for the for example, the sending and receiving the EIGRP updates. Okay, because of that, now we know that one of the most important packets of the EIGRP is the EIGRP hello, and we are using it for the neighborship. Okay, I will talk about the detail of the hello. When we are enabling the EIGRP on one interface, okay, the multicast address, reserve multicast address of the EIGRP should be enabled automatically on this interface. You know it. Also, beside of this function, we have another function. On that interface, the router starts to send the EIGRP hello. This is the EIGRP hello. The EIGRP hello is sending over all of the interfaces that we have EIGRP enabled on that interface. For example, on these two interfaces in the router 1, EIGRP hello, okay, on the fast Ethernet 00 and for example serial 10. Also, let me to say that about the EIGRP hello, the source IP address is the unicast IP address. You know that every time the source IP of a packet is the unicast IP, but the destination can be unicast, multicast, or broadcast. In EIGRP, we are sending these hellos to the, for example, multicast address of the EIGRP means 224.0.0.10. Why? Because we want to find the neighbor dynamically. For example, R1 sending the EIGRP hello from its unicast address means let me to write one of the one for one hello 10.1.0.1. okay, this is the source IP, and destination IP is 224.0.0.10. Why we should send the EIGRP hello to the 224.0.0.10? Because we hope to find one neighbor. We know that the R1 knows that if any EIGRP neighbor is available here, the 224.0.0.10, the multicast reserve IPv4 address of the EIGRP, is enabled on that interface. Because of that, we are sending the EIGRP hello with hope to finding one neighbor. Okay, also this EIGRP hello is sending from 10.1.2.1 to the 224.0.0.10. Okay, you know that the source IP is the unicast. Yes, I know that on this interface we have two IP address, unicast and multicast. Every time the source IP is unicast, and destination IP can be unicast, multicast, and broadcast. Now, as you can see, there are one sending the EIGRP hello on both interface, and also the R2 here. The R2 should send the EIGRP hello on this interface. Okay, the source is 10.1.2.2, destination is 224.0.0.10, and also on this interface, let me to show you, the source IP is the 10.2.0.2 to the destination of 224.0.0.10. Okay, this is the start of the process. I will talk about the detail, but let me to say that now the hellos of R1 that is sending on the serial 10 can be accepted by R2. Why? Because in R2 we have 224.0.0.10 as the one of the IP address on this interface. Because of that, this hello can be accepted by the router 2, and also in router